What is going on, guys? Welcome back. In this video today, we're going to learn how to do named entity recognition in Python. We're also going to learn how we can train custom models for named entity recognition, and both of these things are very useful for various NLP tasks, including the implementation of automated chatbots. So let us get right into it. Alright, so named entity recognition is the task of extracting entities from text. So let me give you a simple example. I'm going to navigate to my working directory, open up a new Python file. Let's say we have a simple text, something like John takes a walk, or John goes for a walk in Berlin. So this text right here is just text. And of course, we can tokenize it, we can extract individual words, but we want to intelligently recognize that in this case, John is a person and Berlin is a location. Or maybe you want to have it more granular. You want to say that Berlin is not just a location, it's a city. So as a result of named entity recognition, we could get something like person, John, and then the position. So maybe person from 0 to 1, 2, 3, 4. So one after the last character. That would be John. The person, then we would have something like Berlin, which is either location or city. So the other way around, location would be Berlin. That is the task of named entity recognition. And this can be very useful. For example, if I have a chatbot that's not GPT based, it's not a large language model, it's maybe intent based. So we're trying to recognize the intent of the user, but then we're also trying to recognize what exactly the user is asking for. So let's say I have a chatbot that can recognize the intent for asking about the price. So the user is asking about the price of a product, and then I could say something like, what is the price of 20 bananas? Just as an example here. In this case, I can recognize this as the intent price. So intent could be price question, for example. But I don't know exactly what we're asking if I don't do named entity recognition. So I need to recognize that 20 is a quantity, and I need to recognize that bananas is the product. So 20 bananas would be the combination, and then I could use a function that maybe works with an API. I could do something like get price of product. And I would get quantity and product as parameters, and then I would do some work. But of course, in order to be able to pass these products here, I need to extract them from any string. So it's not just this string, it's also a string like give me the value of 40 bananas. That would be now a different quantity, also a different structure. And because of that, we do named entity recognition. So what I want to show you in this video is how to do it with a default model, with something that already recognizes certain kinds of entities. And then I also want to show you how you can train your own model, or how you can customize, or you could say fine-tune an existing model to fit your example, so that you can add more labels, you can add more entity types, and you can also provide more training examples to get a better model. And for this, we're going to use a Python package called SpaCy. So we're going to say pip or pip3 install SpaCy, and this package allows us to do a bunch of NLP stuff, a bunch of natural language processing stuff. So once you have this package installed, the next thing you want to do is you want to run a command to download a model. So you want to do python3-m SpaCy and then download, and then the name of the model. In our case here, we're going to use English_core_web_, and then the size of the model. You can go for small, you can go for medium, you can go for large. We're going to go with medium today. So python3-m SpaCy download en core webmd. Once this is done, it's going to be available when you use SpaCy. So in my case here, it downloads it again, even though I think I already have it on my system. And what we're going to do then is we're going to start by importing SpaCy. So again, the first step here is to see what we can do in terms of named entity recognition without fine-tuning or training our own model. We just want to see what an existing model is capable of. And for this, we're going to provide a list of texts. So we're going to say something like John goes for a walk in Berlin. Then maybe we're going to say Mike is going to the store. Then we could say Elon Musk is the CEO at Twitter, which is X, but let's keep it at Twitter. I'm not sure if this model already knows that Twitter is now X. Then we can do something like Bob Smith, to have two names here, is the guy behind XYZ-Soft Incorporated. Just some example here. And then we're going to add an example where I think it's not going to recognize it because the name is maybe not usual. This is my name. I am the guy, is the guy behind Neural 9. So it would be interesting to see if the model recognizes this as a name and this as an organization. So these are my text examples. And now we're going to say NLP is equal to SpaCy.load, and we're going to load the model. So en core webmd. And what we can do here first is we can get the categories that are part of this pipeline, of this model. So we can say NER labels, so named entity recognition labels, are equal to NLP get pipe and then NER. And then we can just print these labels to see what we can choose from. So if I run this now, you're going to see that we have a bunch of entities that we can recognize. Actually, this is dot labels, sorry. We need to do dot labels. And then we're going to see the entities that we can recognize right away. So we can get cardinal, which is just a number, date, event, I'm not sure what FAC is, GPE, language, law, location, I think, money, I don't know what that is, ordinal, organization, percent, person, product, quantity, time, and work of art. So these are the labels that are supported by the model by default. We can add our own labels by training the model or fine-tuning the model, but for now we're going to just work with these. So what we're going to do is we're going to comment this out, and we're going to say, let's try to specify a list of entities that we're trying to extract. We're not trying to extract any entity or all entities. We're trying to extract specific entities. Let's say these categories are equal to the following. We're looking for organization, we're looking for person, and we're looking for location, because that should recognize these names. It should recognize Berlin, it should recognize Twitter, and hopefully XYZ-Soft Incorporated and Neural 9 as an organization. And now we're going to just say that the documents here are going to be NLP text, NLP applied onto text for text in texts. So we're basically applying the pipeline of named entity recognition onto this text or onto these texts. And then we're saying for document in docs, we're going to say the entities, is this spelled correctly? Entities, I think so, yeah. It's going to be an empty list. And then we're going to say for entity in doc.ends, we're going to say if the label of that entity is in our categories, we're going to append it to our entities list. So we're going to append, first of all, the text of the entity and then also what it is. So end text and end label. With underscore. All right. So that is that, and in the end, we're going to print for each text the entities. So I think that should work. Let's go ahead and run this, and let's see if we are successful with all the examples. Text is not defined, yes, because that should be plural. So here we need an S, and then we can run this. And now we get John is a person, Mike is a person, Elon Musk is a person, but Twitter is not recognized as an organization. Interesting. But XYZ-Soft Incorporated is recognized as an organization. I'm actually recognized as a person, which surprises me, and Neural 9 as an organization. So it's not perfect, but it's kind of okay. We can also say that we don't want to have this check, just append all the entities. Maybe we're going to find more in this case. But okay, so Berlin is not recognized as a location, but as GPE, probably this is something location related. I'm not sure what this stands for. Maybe some city or some country stuff. I don't know. But it seems to perform decent. So let's try something else. Let's try to add some examples like the ones that we talked about with the recognition of the intent to buy something or to ask for the price. So let's say something like, what is the price of 4 bananas? And then we can do that maybe, how much are 16 chairs? Give me the value of 5 laptops, for example. So let's try these 3 examples here. Let's get rid of this. Let's get rid of this and this and this. And then just go ahead and run this. And now we're getting only the numbers. So it's not recognizing bananas, chairs, or laptops as products or anything else. We just have the numbers 4, 16, and 5. What happens if I write this as a text? So if I don't say 5 laptops, but 5 laptops as a word. In this case, is it still recognized? Yes, it's still recognized. Okay, so this is not exactly what we want to have here as a result. So now we're going to fine tune the model. Let me close this here. We're going to now train our own SpaCy pipeline. We're going to train our own named entity recognition pipeline. And for that, we're going to need some training data. So first of all, I'm going to delete all of this here. And we're going to import from SpaCy.training.example. We're going to import the example class. And we're going to also import from SpaCy.util mini batch so that we can train in batches. And above that, we're also going to import random because we want to shuffle our training data. But basically, our training data will consist of sentences and also where the entities are located with also the entity label that we're looking for. So we're going to have a bunch of examples here. Let's call this train data. And the train data is going to be just a list of tuples. And these tuples will have the following structure. I will have a sentence like, what is the price of 10 bananas? And this is now my raw sentence. And the next thing here is going to be a dictionary saying what kind of entities we have. So we're going to have here entities. And the entities are going to be a list, and each entity is going to be a triple, so a tuple with 3 elements, and it's going to contain the word, and it's going to contain the positions. So in this case now, the quantity is 10. So how do we get the quantity? We go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21 is the first character of the quantity. And then 22 is the last one, but we need to add one more so that it's included. So 21 to 23 is going to be one piece of text that is going to be recognized as quantity. By the way, you don't have to go with quantity and product if you don't want to. I'm just using these examples because they're already part of the pipeline. You can also come up with your own terms. You can call this hello world or something. You can choose any name you want for the entities that you're recognizing. You just have to train the model to use them. And the other one is going to be, I'm not going to count now, but from 24 to 31, we have the product, which is bananas. So actually in uppercase. So this is going to be from here. This is position 24, and it's going to go until position 32 actually. So 31 actually, because this is 30, 31 includes 30, so we have this. And that's just how we do one example. Now, I'm not going to do this for a bunch of sentences here because it would just waste a lot of time. I already have training data prepared, and if you want to also use training data, you can just ask ChatGPT to generate data like this. Just provide this one example and say you want to have variations of this, 20 or 30 of them, and then you're going to get something like this. So let me just turn this into into lowercase. But basically, we have just a bunch of different sentences here with different quantities and different products asking for the price in various different ways. Give me, could I get, can you tell, I'm looking for, do you have, how about, we need, could I buy, how much are, and so on and so forth. So we have these examples here, and we're going to use them now to train our named entity recognition model. And we're going to do that by either creating a blank model, or as before, we're going to just load an existing model and we're going to, so to say, fine tune it. So SpaCy load, and we're going to load again NCore Web MD. And we're going to say if named entity recognition is not part of the pipe. So if we don't have NLP pipe names, if we don't have that in the pipe names, we're going to create a new pipe. So we're going to say NLP.add pipe, and we're going to call this pipe NER, named entity recognition. Otherwise, we're going to get the existing pipe. So get pipe NER. So either add a new one if it doesn't exist, or get the existing one. And then we're going to add labels if they're missing. So now we have quantity and product. They're already part of the model, but we can of course add more of them if they're not, or we can add new ones if they're not included already. So we're going to say for placeholder and annotations in the training data, so the train data, for entity in these annotations. So the basic idea is we get, of course, the left part, which is the text, and then we get also the entities. And in this dictionary here, we have this value, and from this value, we want to have the third position, so the label, and we want to add it to the model if it doesn't exist in the model already. So we're going to say if the entity is not in NER labels, if that's the case, if that's not the case, we're going to say NER add label, and then we're going to say annotations, or sorry, entity 2. Actually, I think we need to do entity 2 here because we're asking if this is part of the labels, and then we're adding it. All right, so that's the idea, because if I use something like pet or animal or something like this, it's going to have to add this to the model. Otherwise, the model cannot work with this entity. So the next thing we're going to do is we're going to disable all the other pipes of the model, except for the NER, because we want to do training. So we're going to say the other pipes are equal to pipe for pipe in NLP pipe names if pipe is not equal to NER. So this gives me all the other pipes, and then we're going to say with NLP disable pipes, and we're going to unpack all the other pipes here. So with those pipes disabled, we're going to define the optimizer to be equal to NLP begin training. So this returns an optimizer. And we're going to say epochs is equal to 50. You can, of course, adjust this if you want to. And then for each epoch, so for epoch in range epochs, we're going to shuffle the training data. So random shuffle train data. And we're going to, actually without colon, we're going to keep track of the losses here, and we're going to say the batches that we want to process are going to be mini batches. We're going to take the train data, and we're going to say that the batch size is whatever you want it to be. In this case, we don't have too many examples, so I'm going to just go with the simple size of 2. So we have a batch size of 2, and then we're going to say for batch in batches, examples are going to be an empty list. And now we're going to say for the text and annotations in this particular batch. So again, text is the left side here, and annotations is this dictionary here. For this, we want to say make this a document. So turn this text into a document, NLP make doc text. And then the example that we're using here is going to be an example instance. And we're going to say from dictionary doc annotations. So we're basically providing this together. Then we're going to say examples, append example. And then we say at the end of this iteration, NLP update examples. We're going to say drop equal to 0.5, which is the dropout probability. And then we're going to say losses is equal to losses. And finally, we're going to print the message that this particular epoch is done. So we're going to say, after all the batches are processed, we're going to say formatted string epoch, or actually epoch +1 here in curly brackets. Losses is going to be losses. All right, so that is our logic. So again, to recap briefly, we have these examples where we specify this is the text, this is where I find my entities, this is the entity type. And what we do is we add a pipeline for named entity recognition if the model doesn't have it. We get it if it already exists. We are adding all the unknown new entities. In our case, we don't have any. But if I had animal or city or country, they would be added to the model. Then we're disabling all the other pipes, and then we're going for the training. We're having a mini batch size of 2. We're training the model, and basically that's it. We're fine-tuning it. In the end, we can also say NLP to disk. We can save the model if we want to. Let's call it custom NER model. And then we can load it again. Trained NLP is going to be equal to SpaCy load, and we're going to load the custom NER model from disk. And the only thing left to do is to then evaluate it. For this, I'm going to use these 3 training examples here. Very simple. How much for 3 oranges? I want 15 chairs for the conference. Can you give me the price of 6 desks? And that is going to be our test set, so to say. We're going to say for text in test texts, and we're going to say doc is equal to the trained NLP applied onto the text. And we're then just going to print formatted string text text. What's the problem now? There you go. Text text, and then we're going to say print entities are going to be whatever we recognize here. It's going to be entity.text, entity.label as a tuple here for entity in doc.entities. That's going to be it. And that is the final thing. The only thing left here is a line break, and then we can run this and we have a syntax error. I forgot an in statement here. So if it's not in NLP pipe names, besides that, hopefully it works. NER is not defined. Where is it? NER labels. It should be NLP labels, of course. And we also have no attribute labels. Okay, what is the attribute then? No, actually it is NER. Sorry, we need to say it is NER, but we need to add, or we need to set NER equal to the pipe. So basically when we add it, it's returned, and when we get it, it's obviously returned as well. I just missed storing it into a variable. But now you can see the training happens, the loss is going down, and after 50 epochs, we hopefully get the correct responses, which are 3 oranges, 15 chairs, and 6 desks. So this works very well. And you can, of course, extend this. You can have more examples. You can have, of course, also you can use a tool like Label Studio, or you can write your own tool to label this data more efficiently. You can use ChatGPT to do it, whatever. But the more data you have, the more accurate this is going to be. You can use many different categories. You can do a bunch of different things with this here. But this is how you can do simple named entity recognition in Python. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.